Assalamualaikum guys, welcome to another video of study with ARS. So today's our topic is bond formation over axis. So we have got three types of axis: x-axis, y-axis, y-axis, and the last one is z-axis. Means there are a lot of shapes which are based on these three axes. Okay, so this one is the means x-axis, this one is y-axis, and the last one is z-axis. Okay, so let's go with the bone formation over an x-axis. Okay, for example, if we are going with the x-axis, so here we have to take an example like means this one is a s orbital. Okay, of anyone. Okay, let's take an example of hydrogen. Okay, this is the hydrogen orbital, which is a s orbital, because hydrogen contain only one electron, and one electron used to fit in s orbital. Okay, and this is the other hydrogen, which is also having a one electron. Okay, and it's used to fill in means it used to fill in s orbital, because both the hydrogen in atomic form are in means having one electron, and they are means the electrons are in s orbital. Okay, so now if they wanna share their electron to means get stabilized, so what they will be doing, they will be sharing or making bond. Okay, so it will be doing like this: H2 means there is a bond, and now between these two, for example, this one is means first or s orbital, and this one is second s orbital, and now they will be sharing here the electrons. Okay, so it means this they are sharing electron, and this sharing is happening happening between two s orbital and over x-axis, means they are over a plane of x-axis. Okay, this one is x-axis and this one is y-axis. So this bond is happening between over an x-axis, so this one bond is called x-axis bond, and the name of x-axis bond is sigma bond. Okay, so the definition of sigma bond is that a bond formed between means head to head bond forms called sigma bond. Okay, one form, that means the head to head, all the bond which are formed by head to head called sigma bond. Okay, so here we got another type of a bond which is over a y-axis. So let's look at the example of a y-axis bond. Here we are having y-axis. So now let's look at the example of y-axis. For example, here we got a p orbital. Okay, and here we are also having a p orbital. Okay, suppose this is a and this is b. Suppose these are not elements, these are means just numbers or variables to denote them. Okay, so these are the means this for suppose that this p orbital is a half filled means this is a half filled orbital, and the p orbital is also a half filled orbital of an atom. Okay, so if they wanna get stabilized, so they wanna make a bond, so how they will make, but I want to clear one thing here, that they are already in a sigma bond, means like this, they are already in a sigma bond, and this is not over a means x-axis or y-axis, these are like this, they are on x-axis. Okay, according to this they are x-axis. If I will draw like this, for example, this one is this one, and this one is this one. Okay, and this one is denoting here this one, and this one is here. Okay, so they are on a x-axis. Okay, so they are already bounded in a means sigma bond. They are already bounded in a sigma bond. Okay, so this one is x-axis, this one is y-axis. Okay, so they are already bonded in a sigma bond. So now if they have a means one more valency shell, or they are still incomplete, so what they will gonna do, they will make another bond, but this bond will be side to side sharing. For example, like this one is the p orbital, and this one is the p orbital. Electrons are here, so this will be the sides wise sharing. Okay, means they are connected like this and like this. They are connecting like this. For example, consider this is the means one orbital, and this one is the other orbital, so they are connected as a sidewise. Okay, so like this. And consider, for example, if we are having a pencil like this one, this one this one is the eraser. Okay, and the other one pencil is also attached there sidewise. Okay, so means this bond will be called as on a y-axis bond. Okay, this bond will be called as a y-axis bond because they are means on a sidewise. The means rule of x-axis was they used to be in head-to-head bond. Means they always means placed in a x-axis plane. So let's look at here in which axis they used to come. This one is x-axis and this one is y-axis. So completely they are coming on a y-axis. So we can call them as a means y-axis bond. And the name of a y-axis bond is known as pi bond. So let's look at the definition of a pi bond. Okay, so pi bond is defined as that the means side to side share, side to side interreaction, side to side interreaction is called pi bond, and it is on a means y-axis pi bond. Okay, so this one is a pi bond. So now let's look at the last one, which is on the z-axis. Okay, so let's going for the z-axis. So here we are having the axis. Okay, so like this we are having one orbital, the other one is like here. Okay, these are on a z-axis. Okay, they are overlapping. Okay, so firstly let me clear one thing, that all the atoms are overlapping each other. They are not bounding like this. They are means on a y-axis, but they are means bounding or like overlapping. Okay, like this one is a pen and this one is the another pen. Okay, so they are on a means overlapped form. If they are like this, so means this is a sidewise sharing, and this one side to side is called y-axis because they are on a y region. And if it is like this, means they are overlapping like this, and means x-axis. So this one is called x-axis bond. Okay, and the last one is z-axis. So z-axis, let me clear one thing. Okay, so z-axis is a thing which I draw here. It need a 3D animation. So let's look at this one. You may say a square. Okay, so this is something like this. Okay, they are having another dimension. Means they are three dimensional. So because of that, I cannot draw here as a means full means they are on a if I need a means whole to draw them. Okay, so because of that I cannot draw clearly the z-axis, but they are like this. Okay, so if they are also means uh, they are needing of electron, they are means they are having free electron, or means they want to share the electron, and so how they will be doing, so they will be doing like this. They will be overlapping on a z-axis. So this one is the z-axis, and so let's create the means like this. So this one is this one is y-axis, this one is x-axis, and the last one we have got is z-axis. So the bond forming on z-axis is called z-axis bond, and it is also known as pi bond. Okay, let's clear one thing, that if there would be a means sigma bond, then there would be a means pi bond. Okay, no matter it's a y-axis or a z-axis, if there is a sigma bond, then they will be forming the pi bond. Okay, so I have given example here as well, means they are connecting as a sigma as well, but there is another orbital. So how they will be doing like this, they are on a x-axis and they are connected in a sigma bond, and if in this one orbital want more electron, and this is also means having a capability to means share electron, so they will be doing like this. Okay, they will be on a y-axis, they will be on a y-axis, and this one orbital on a x-axis. Okay, so this is the example of y-axis bond, and so this was our today's topic. Hope you guys enjoyed. We'll see you in the very next video.